Right, this is kind of a pretty neat application. This series here, adding up a half plus a half squared plus a half cubed plus a half to the fourth indefinitely. We know this is a geometric series, and we learn how to solve this when we cover sequences and series. But let's figure out what is this sum equal to using basic algebra. It's kind of neat. So back to this equation, we're trying to solve this rational equation. What is this sum equal to? Well, whatever it is, we'll call it x. So let's do this. Let's multiply both sides by a half. This is a half x. When I multiply this side by a half, we get 1 over 2 squared, 1 over 2 cubed, 1 over 2 to the fourth, so on and so forth. All right? Now up in this equation, if I subtract a half, we get x minus a half is equal to, when I bring this over, we're left with 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the fourth forever and ever and ever. Well, we see 1/2 x equals this sum. X minus a half equals the same sum, and by the transitive property, this, therefore, 1/2 x has to equal x minus a half. Yeah? So now let's solve this. If I subtract x from both sides, 1/2 x minus 1x is minus 1/2 x equals minus 1/2. And if I multiply both sides by -2, we get x is equal to 1. Therefore, 1 plus a half plus a fourth plus an eighth plus a 16th, forever and ever and ever, all the way to infinity, that sum converges, and it converges to our number 1. Kind of cool.